Hey everyone, hope you're doing well. So in this video, I'm going to give you a quick tutorial on how to create a 3-bus network in PowerSET. So if we go off to the left side of our screen here, when we first open PowerSET, you'll see that we have a list of all of our records, but because we have a new network open, we shouldn't have any records. And we can sort our records by facilities or memberships, but we're just going to focus on our simple 3-bus network. So let's just stick with facilities, and you'll see under facilities, we'll have a list of buses, generators, lines, loads, etc. So with buses selected on the top left, I'm going to go down here and click add. Now at the top of our window, you'll see that we can choose between per unit or actual units. This determines the units that we enter in for our bus. So if I select actual units, you'll see that all the units to the right here change to kV, versus if I go to per unit, you'll see that they all change to per unit, but we'll keep it at per unit for now. So let's go to our identifiers. We have ID and name. These have to be unique, and this is auto-populated. And ID of 1, we'll go with that. And then name, we will choose Phoenix. That works. And then below we have area ID, substation ID, zone ID. These are default 0. That's the unassigned. We're not going to worry about those memberships for now. And then below, location, latitude, longitude, we're not going to worry about that either. Below, more importantly, we have controls. We have our control mode. We can select between reference bus, V delta bus, PV bus, and PQ bus. Phoenix is going to be our reference bus. This is also known as your swing bus or slack bus, so keep it at reference bus. Base voltage, let's choose 100 kV. For scheduled magnitude and phase, let's keep that at 1 per unit and 0 degrees. That's standard. And enforced Q limits, that's not applicable. That's only for the PV bus. And then for the ratings, we'll keep those at the default value. So I will hit add. And you'll notice after I hit add, it looked like nothing happened. But actually at the top, you'll see that our ID incremented to the next available ID, which is 2. And if I move my window here, you'll see that we now have a bus added to our list of records, and then even in the system log down below, it says that bus Phoenix added to network. So that's how we know it was added. So I'll move my window over a little bit. And instead of Phoenix, this time, let's do Mesa. And then we can only have one reference bus in our network, and Mesa is going to be a load bus, so we will choose PQ bus. And then that's the only change we need to make, and we will hit add. And then next, let's choose Gilbert. And then we can have as many PQ buses as we want, obviously. So we'll just hit add and then cancel. And now we have our 3 buses. And next I will select generators. And now I will add a generator. Again, I can choose between per unit or actual units. Usually with generators and loads, we like to work in megawatts and megavars. So I will keep that at actual units. And ID, this has to be unique. Then we'll choose 1. But you'll notice that we also have a bus with ID 1, and that had to be unique. Well, the ID only has to be unique to that facility. So we can have a generator of ID 1 and bus ID 1. That's not a problem. So I will keep that at 1, and then I will give it a name, Phoenix Gas Turbine 1, GT1, and from bus. If I click these 3 dots off to the right, it'll give me a list of buses to choose from if I can't remember the bus number. But in this case, it's pretty easy. We only have 1, 2, and 3, but I'm just showing you, so I'll just choose 1. And then circuit ID, this just has to be a 2-letter identifier, and the combination of front bus and circuit has to be unique, but we'll just leave it at G1. Again, area, substation, zone, we don't care. Status, that should be obvious, open, closed, and service, out of service. So we want closed, and then regulating and fixed. A bit more complicated. If I were to choose fixed, it would output exactly whatever I put in the P and Q scheduled. And then regulating, it will output P and Q in order to control the voltage. So because this is a swing bus, it will output both P and Q to control voltage. But if this were a PV bus, then it would output whatever P value I entered, and then it would it would solve for a Q value for the output. So I'll just leave these at 0. It's not going to really matter for a swing bus generator. And then for limits, let's just keep these at the default values. If this was a real power system, you would want to actually enter in the generator limitations, but we'll just keep those. So we'll hit add. All right, so now we see our generators add to the network. Next, we have lines. Again, we have per unit or actual units. If I were to select actual units, we have microsiemens for our conductance and susceptance values, and then we have ohms for our resistance and reactance, but we want per unit. It just makes our life easier. So ID, we'll keep that at 1, and then line, let's choose Phoenix Mesa 100 kV line. All right. This can only be maximum of 16 characters, so I'm shorting the name a little bit. And then from bus ID, let's choose Phoenix. And then let's choose Mesa. Circuit ID 1. And then we'll skip the memberships. We want status closed. Length of the line. This is purely informational. Doesn't mean anything. But let's just choose 6. Conductance and susceptance, these are the shunt values. Let's just assume that they're negligible on this line to keep things simple. This is purely for demonstration purposes. And then for R, I'll choose 0.01, and then reactance is roughly 3 times resistance, so we'll just do 0.03. And then a rating, we can choose between MVA and amps. I like amps, so we'll do amps, and I'll do 1600 amps for a normal rating, and then 1800 amps emergency rating. We're not going to worry about closing angle violations, so we'll uncheck that box. I could also keep the value at 0. That will disable it, even if the box is checked, but let's just uncheck the box. So I'll hit add, and then you'll see that ID incremented. So now we have a line added. Instead of Phoenix Mesa now, we'll do Phoenix Gilbert. Trying to respect the 16 characters there, so... and then from bus, we'll keep that at 1, but now we want our 2 bus to be Gilbert. I could also just edit this. I can make that a 2 or 3, but I like using the bus finders, so make sure I'm got the right name matched to the bus ID. And then let's make this one 8 miles, and then maybe this will be 0.015. And then we'll do 0.045. And then we'll keep the same rating. We'll hit add. And then instead of Phoenix Gilbert, you probably know what's coming. We have Mesa Gilbert. And then that will be bus 2. Maybe this is 4 miles. And we'll say it's 0.008. And then 0.024. That should add up. And we'll hit add. So now we have 3 lines. Last, we will add loads. So for the first load, let's do Phoenix GT1 station service. So we'll choose bus Phoenix. We'll give her the circuit ID station service, so we know it's a station service load versus, a residential or commercial load. We'll skip the memberships, controls, close obviously, and then let's make it 1 megawatt and 0.07 or 0.07 megabars. So we'll add that. And then let's add a load on our Mesa bus. We'll call it Mesa L1. And then that's on bus 2, pretty sure, yep, bus 2. And give it circuit ID L1. And maybe that's 60 megawatts and 10 megabars. And then we'll do Gilbert. GIL Gilbert. Load 1, and maybe this is 55, and then this is 8. And let's select add. Okay, so now we have all of our equipment added to the network. So the next thing we need to do is solve it. So I will go up to the top here where it says solve, and I will click solve. And looking below, it says solution converged in 3 iterations. That means that we have a solution. Next, let's draw our one line so that we can view the results. But before I do that, you could also just click on the bus and click edit, and then this will show you your solution results. But this is a little hard to view all of your data. You want to see your line flow and your voltages for all of your equipment at the same time. So while you can look at individual buses this way, it gives you a little bit more data particular to that bus. We want to draw the bus. So I will select the Phoenix bus, and then up here where it says add bus to one line, I will click add bus to one line. And then you'll see that my crosshair turned from the default cursor to crosshairs, and I can select anywhere in our black one line panel here, and I will click. So you will see that this added the Phoenix bus with the generator and load that is connected. And then at the top, it gives you the bus ID, the bus name, and base kV. And below, it gives you the solved voltage in kV per unit and the phase angle. So this is our reference bus, so we would expect these values. I'm going to add buses later, or the adjacent buses in a second. So I'm going to right click on the generator and click rotate generator. And then I'm going to right click on the load and click rotate load. So I want those on the left side. And then I'm going to right click on the bus and then click add adjacent bus and select Mesa. And again, I have the crosshairs. I can select anywhere I want, but I want that off to the right. So there's my Mesa bus. And then, so I can select this little black dot on the bus for the line, and then click and drag anywhere onto the bus. So, that's a good spot for me. And then I'll keep the load where it is over there. And then I will right click on the Phoenix bus again, and then click add adjacent bus. And then I have Gilbert. So I will select that, and then I will place that somewhere below. This is a little ugly. We have our line crossing our load here. We want this to look nice and pretty and have, right angles. So what I'm going to do is I'm going to right click on the bus and then click rotate bus. So that rotates my bus. And then I want to rotate my load so it's below the bus. And then it looks a little better, but then, I have these lines and then the text is overlapping with the bus. I don't want that. So I'm going to right click on the line and select add pivot point. So that adds a pivot point to my line. So now I can make it have right angles. Right. I'll select a pivot point over here. So now I have right angles over here. So now everything's roughly at a right angle. But maybe that's not good enough for me. Maybe I want to have a pivot point here and then another pivot point. So my power system looks something like that. All right. And then some more features we could add. I'm going to right click on this segment here. I'm going to click add meter point. So this gives me a pie chart with the percent loading of this line. And I'll do so over here and over here. So those are my values. While I'm doing this, I'm going to go ahead and save. Go to desktop here. And then I'm going to call this Phoenix Network. That works. Okay. So I mentioned earlier that the scheduled P and Q values for the generator don't matter on the swing bus. So you can see here on the generator, it's outputting 116 megawatts and about 21 megavars, and it completely ignored what we entered in for the P schedule values. That's to be expected. So right click on the generator. Actually, I'm going to unselect edit mode down here and then right click on the generator and select view solution. So this automatically takes me to the calculated values. And you'll see that the power injections are listed here along with the magnitude and current, magnitude and phase angle of the current. But if I go to parameters, you'll still see that P and Q are at 0, but these are the output values. If I were to change this to fixed, save, solve, then my generator outputs exactly what the P and Q scheduled is. But this will still solve because you have to have your swing bus outputting P and Q values in order to reach a solution. But you'll see here that you get an error that reference bus Phoenix has no connected regulating generator. So you really don't even have to have one at all, but good practice would be to have one. So I'm going to change this back to its original values. And then We go to regulating, save, solve. So there we go. So next thing I'll do, maybe I want to simulate a contingency. So I will right click on this line and I will click toggle status. You'll see that this all changed to dotted lines, which indicates that it is out of service. And then I will click solve. And then you'll see that our loading had increased on both of our lines, and then our voltage dropped on both of our buses. Maybe I want to check if we have any voltage exceedances. So instead of color by base kV up here, I will choose color by exceedance. So now, because all of our values are gray, that indicates that there are no exceedances. And then for our pie charts, we can either choose percent normal or percent emergency. So I will choose percent emergency, and you'll see that these drop down to the percent emergency values, which makes sense because our emergency amperage is lower or higher than our normal amperage. So I'm going to go back to our regular values. Maybe I don't like this cyan color, so I'm going to go to network settings and then one line settings and then edit base kV colors. So maybe instead of cyan, maybe I like green. So I will select a green color. Click OK, and then click Save, and you will see everything turn to a green color. Maybe I don't like the black background, so I will choose a different background. Again, in one-line settings, I'm going to click the dots over here, and maybe I want a gray color, so I'll select gray, and hit OK, and then Save, and now we have a gray background. And then if I use my wheel, I can zoom in and out. And there are no limits to how far you can zoom in and out. And then if I want to pan, I can press Shift. Ooh, it does not look good with the gray. But I can press Shift, and then I can hold down, and I can move my diagram around. All right. Well, I hope you all learned something from this video. Take care. Bye.